Recording progress.
Hi, everyone. Good afternoon. My name is Ray, and I'm really happy to share our findings on which entitled Automatic Explanation Generation for Climate Science Claims. And this is a work, collaborated work by with Shraey and supervised by Timothy Baldwin and Jehan Lau. And so let's see what it is. So first, a 1 minute background. And as Jay has talked yesterday, fact checking is really important. And the climate change is a very serious challenge. And the widespread of unchecked claims is manipulating public perception. And here are two claims, which are both false. And let's take a bit closer look at the second claim. Sea level rise is not accelerating. We say it's false because we find some evidences that refute the claim. And so here are two evidences. You can have a quick look. And this is a framework that we're using for automated fact checking. So this is what we call retrieval augmented generation. First, we do claim detection. This step is to detect which claims are check worthy. And we researchers have made their own data sets, claimed it for fact verification. And then we retrieve evidence from external knowledge bases. And then we predict verdict veracity labels. And then we do justification production. So in our work, we are focusing on justification production. We are generating explanations, trying to justify our predictions. So this fancy work is, this picture is taken from this fancy survey. And first, let's take a look at our data. There are two key data components. The left is external knowledge source, and the right is paired claim explanation data to serve as the input and the output. This is what we are doing our experiment on. This is our knowledge base. Let's take a closer look at this. First, external knowledge source, and the cylinder represents the knowledge source, and the square represents each document. Here in our experiment, each document has 100 words, and our knowledge source contains two parts, PubMed and IPCC. PubMed, I'm pretty sure that some of you have been really familiar with this. So this is basically a medical database. And we filter using mesh. We extract those climate science related abstracts. And for IPCC, it is short for Intergovernmental Panel on Climate Change. There are two features I want you to pay attention to. First, it's written by a mix of scientists, experts, and policymakers. And what knowledge it contains scientific, technical, and socio-economic knowledge, which means it has it is very related to climate change. So why we are choosing this knowledge source, another reason is that we are following our previous work to make a fair comparison. So this is our paired claim explanation data. We're using climate fever. This data set is used for climate change fact checking. It contains many climate change related claims and related evidences. The label system contains support, refute, and not enough information following the fever style. And here we have text and label. The C represents the claim, and it has each claim has five related evidences from E1 to E5. Okay, so this is our framework. Overview of a method is to retrieve documents and generate veracity label and explanation together. So here are two main parts. The left is retriever and the right is generator. So basically what we put our more focus on is on the generator part. We are not fine-tuning or doing any further training on the retriever part. So there are three steps. The first, the claim is used as the input to BPR to retrieve top K claim retrieve passages. We're just using the off-the-shelf retrievers. Yes, we're using BPR is an advanced version of DPR. And the second step is the claims or passages are concatenated with the doc sub tokens for input to Primera. Primera is state of the art, which is probably not now, but by the time we're doing experiment, it's the state of the art multi-document summarization model. And the third step, finally, Primera generates explanations together with the veracity label. So let's first take a quick look at the overall performance. We are using BERT score root 1 and root L and accuracy to measure this automatic metrics. So FID represents the fusion decoder, which is the baseline model. I'll tell you more in the post session. So P claim, which means that we are using only using claims without evidence to see let's see how Primero works on this. And P4 which means that we have evidences and claims. So we can see that it seems promising. And for generated examples, the result is generated examples constitute plausible explanations. These are two good examples, but we are more aware of the error analysis, which means that we sample 50 samples with the lowest root scores to perform some manual analysis to categorize 4 types of errors they're making. For the explanations. So we can see that the insufficient explanation account for 57.6%, which is the dominant reason that it produced some errors. Insufficient explanation means that the explanation generated are talking some related topics, but not directly justify the prediction. So here are some detailed, here's a detailed table that has some samples that belongs to 4 category. So yeah, you can have a look at the post session. Okay, so what's the conclusion here? So first, high proportion of insufficient explanations. So we have high proportion of insufficient explanation and low of claim copying and hallucination, which means that insufficient explanation is the dominant reason. And we have take a closer look at all these insufficient explanation samples, and we can conclude that it's mainly a retrieval problem. Retrieve passages not containing enough information. So if the passage not containing enough information, if we have a very good summarization model, we cannot generate a very faithful, good, plausible explanation. So another ablation study, we're doing different global attention settings that tries to see how different global attention affects the whole performance. So the result is additional global attention really helps the model to focus on claims to generate better and more consistent explanations. Okay. And here's the summary. In our work, we use retrieval augmented generation for veracity prediction and explanation generation in climate science. Basically, it's explainable fact-checking on climate science claims. And we frame explanation generation as a query-focused multi-document summarization task. Here, the document are evidences. So the explanations are summaries which we try to generate. And last, we adapt Primera to the task by adding additional global attention on claims. So which makes it more focused on claims when generating explanations. So thank you. And this is